today's 3D Solutions Spotlight, we will be covering a few topics here. SOLIDWORKS Premium, Part 1. So in today's session, we will be talking about the SOLIDWORKS routing add-in that's available in Premium, right? Of course, SOLIDWORKS Premium Part 1, everything I show here is going to be highlighting some of the features in that SOLIDWORKS Premium level here. Right, so of course the routing add-in, you may have heard it, some of you may have seen it as well. And then we'll be talking about the flattened surface that's available in Premium also. So any type of labels or maybe some fabric type wraps going over geometry you can create with SOLIDWORKS as well. And also the assembly level costing. And then we'll save some time here at the end for a question and answer session. So again, this session should be pretty short and concise, probably about 30 minutes, and then question and answer session there at the end. Right, so first off, we'll talk about routing. So routing allows you to create different types of routes as a subassembly in the assembly, right? So it creates a subassembly and it contains your route components and your route parts. So you can create routes for electrical, so cables and wires, ribbon cables as well, any conduits, piping and tubing, HVAC ducting, so on and so forth. And you can use this routing add-in in SOLIDWORKS to help you streamline that design and development process, eliminate errors, and decrease time to market, and of course lowers cost because you can use all the capabilities in SOLIDWORKS to make sure that your designs meet your requirements there. Right, so we'll go ahead and jump into the software here. There we go. All right, so we will be working with this whole packaging line here, not the entire assembly, but just a certain aspect of it here. We will be focusing on this pallets dispenser here. And so if I go ahead and open this up, you can see that we have this control box. It contains, some PLCs and some other components here as well. So I'm going to go ahead and switch to the configuration that we're going to be taking a look at here. All right, and I'm going to go ahead and zoom in into this panel. So the first thing that we will be taking a look at here is just, again, the electrical cabinet here, and we will be starting by manually creating this main three-phase electrical power cable that's going to connect to this disconnector here. Right. So I already have the add-in turned on. You can see here SOLIDWORKS routing, and we get electrical, piping, tubing, so on and so forth. Right, so we can go ahead and start this route simply by showing some route points here, and then I can go ahead and select that, switch to my electrical tab, and we can start this route by starting at a point. So with this point selected, we can go ahead and choose the properties for the route that we want, right? Cable, wire, or harness, the OD here, and of course add some coverings as well. I'll go ahead and choose the template that I want to use for the subassembly here, and it automatically goes into this AutoRoute mode. I'm going to go ahead and escape out of this for now. I only have one point started here, and you can see the stub length for that wire get created. So since I just started at that point, I need to tell SOLIDWORKS what other components I want to add to this route. So I can go here and see this other route point here. I can simply right click on it and say add to route. So it'll create the other stub length here for that specific component. And then I can go ahead and do the AutoRoute now. So right now I'm going to go ahead and uncheck the orthogonal route because this is going to be flexible wires or cables, right? So I can just go ahead and simply click on that point there. Select this one here, and you can see SOLIDWORKS automatically join those two points with a spline. So I can go ahead and click OK here, and that's the spline that gets created. That's going to pretty much be the wire that we're going to be adding to this here. If we want to add some more connectors here, we can, and we can go ahead and split the route. I'll go ahead and split the route somewhere about here. Creates that junction point, and then I can go ahead and add the rest of these to the route as well. We'll create those other stub lengths here. Now I can use my sketch tools to either manually create some splines to join those to the junction point, or I can go back in here and use the AutoRoute. Pretty much does the same thing and automates that pretty nicely here. So I can go ahead and select that, say OK. And if I'm going to be doing this multiple times, I can go ahead and pin down this tool and select these other routes as well. Just like that. So we'll go ahead and say OK. We're done with that tool. And there's the wires that create this cable here. And of course, we can route this a little more cleanly through these clips. So all we need to do that is say route through clip, select the spline. We can zoom in here or use the magnifying glass. Select that there, and it routes automatically through that clip. Go ahead and do that a few more times. And one more here. Just like that. All right, so we can still play around with these spline handles and move them around as needed. Of course, we can still apply the relations, right? So that's going to be tangent there with that splice and the original cable. So we can go ahead and do that there. Now, so far, all we've done is created these splines, right? Or had SolidWorks automatically create them by saying the route from this point to join this other spline here. That's going to be the wires. But we haven't added any of those wires that contain that information there. So we can go in here and say edit wires. And this is pulling from a XML file that you would create that contains the information for all your electrical attributes here. So you can see here I have my power cable 3-phase. We can go ahead and say OK. And it's taking that information and it knows it has this material right there. And then all I need to do is tell SolidWorks what these pertain to. So if I go ahead and click here and say select path, I can go ahead and select this one here. Now it's letting me know that this doesn't meet the requirements for the selected bend radius for that specific wire or cable. So it's saying, do you want to route anyway? So we're going to go ahead and say yes. So it's pretty much doing that error checking there, letting you know, like, hey, this is going to be putting a crimp in your wire or cable. And as I go through and selecting this, you can see those wires get added, and this cable gets a little bit fatter, right, because it's taking into account all those ODs there. So we'll continue along here, add some additional ones, then we'll say OK. All right, so you can see here that it has some information for those, the wire lengths there as well, the from to references there, and any of the properties for that specific wire. Right. We'll say OK. So of course we can go in here and fix this. If we right click on that junction point, we can show the sketch or triad and try to adjust these manually to kind of smooth out those routes that have the errors there. Or if you're having trouble doing that, you can right click on that route and see what SolidWorks can do for you with the repair route option. So you can see there that it's going through the back of this panel. You can add additional spline points and fix that and drag them around, or you can right click, your mouse cursor is giving you some feedback there to take a look at some other options. So I can continue right clicking here and see what other options get generated. I'll just go ahead and click on this one and say OK. If it goes through the back, you can always adjust that later. All right, but for the sake of time, I'll just go ahead and accept any of these solutions here. That one looks pretty good. Right. Then we can go ahead and exit the sketch. It'll rebuild and generate the wires and cables. Again, this one is going through the back panel of that there, but if I wanted to, I can go ahead and adjust and fix that spline there. Right. So just like that, I created this power cable here. Again, starting with a point. So those C points are those route points can get created on these components and then added to the route like I did here manually, and then go ahead and create this here. Now we have some other components here in this other configuration for the front door lights. So when I switch to this configuration here, right, let me go ahead and save this here. Oh, one thing I forgot to point out, let me switch back here. What got created there is the cable 1 subassembly right here. So this subassembly gets created. If I expand that, you can see that has the route parts, which is the cable there. If I had any additional connectors, that would get saved in that subassembly as well. So I have my options set to save these subassemblies for these routes as virtual assemblies here. You could, of course, set the option to save them externally. The reason why I like working with this to save them as virtual components first is if you mess up, you can simply just delete that and it won't have another assembly file that keeps getting created and added into your project folder. So I usually like running it like this, and then once I see that this is exactly what I want, then I can go ahead and save this as an external file on my drive. Right, so just the workflow there. Right, so we'll go ahead and switch to the Open 2 configuration. Now another way to create these routes and have SolidWorks pretty much leverage the power of SolidWorks routing capabilities here is to use a from-to list. Right, so I can say start by from-to. Now what this from-to list is you can create this in third-party software and create that XML file or Excel spreadsheet there, pretty much listing the components and how they connect to one another, and then have SolidWorks create that for us. So I'm going to go ahead and choose this from-to list for the front lights. And that from-to list, it contains a list of all the components. So if the components are already listed in the assembly, or not listed, inserted into the assembly, it will go ahead and leverage that information in those components. If it was not in the assembly, then it would have a list of those components that are contained in that from-to list in the property manager, and then you would just say insert components, and then you would place them and mate them wherever they needed to be. And then now that they're in the assembly, you can do what we're doing right here. So I have the option to AutoRoute, and what we're seeing is pretty much those splines that were getting created like we saw with the first example, but these are called guidelines. So this is pretty much using that from-to list, saying from this component to this pin on this component here, and it's pretty much showing you a preview of those guidelines. So what I can do is go ahead and box select all those here, and say merge these guidelines to form routes. Right. So that went ahead and bundled those. We can go ahead and say, okay, we're done with that here. Now that from-to list also contains the attributes for these wires, which wires to use in each of those as well. So when I exit out of this route sketch, you'll see that right there. Right? So if we ever needed to make any changes to this, we can go ahead and right click on that and say edit route. We can again route through the clips, or you can use the AutoRoute as well and say reroute the spline. Select the spline there and you can route through this clip. Make sure you click on the proper axis there and it'll go ahead and realign that. Right? So we can do one more. Like so, and we'll say that's pretty good. So you can obviously see this cable going through the door panel here. So if you wanted to, you can go ahead and add a point right here and split the route, and you can activate that sketch or triad again and give it some slack to make sure you have enough slack there for this door panel to open and close here. So we'll go ahead and say OK. And there we go, right? So again, routing, you can do things manually or use the automation built in within the tool here as well to very quickly and easily create these electrical systems like you see here as well. Right, so if I go here and activate this here and just show all the components, you can see all the other electrical routing or routed components here as well, right? So again, this can save you a lot of time, reduce errors, and pretty much automate those processes here and streamline that design and development process here with electrical routing, right? So that's the electrical routing. Let me go ahead and close this here and show you the piping and tubing functionality. So the piping and tubing functionality works very similarly to how the electrical side of things work with routing here. And so let me go ahead and close out this packing line assembly. And I'll go ahead and open up another example here that shows the piping and tubing. Any questions so far? If you go to your GoToWebinar panel, you should see a section for questions. You can go ahead and type in questions there as well. I see one here. Let me go ahead and address some of these. Let me take a look here real quick. Okay, so I have a couple questions. Are there, or is there a standard library of wires that comes from, or that comes with SOLIDWORKS Premium? So the XML file that comes out of the box with SOLIDWORKS has a very, very basic set of wires there. So you would really need to customize that a little bit using the wizard, and it's pretty easy to do. So if I go here and show the routing library manager, this tool can be used to pretty much turn any SOLIDWORKS components that you have into those intelligent routing components there that has those, that would contain the information for the route points. So that kind of answers another question there. Are the route points embedded at the individual part level or added at the assembly level? You can create them at the part level, and if you insert them at the assembly level too, I believe you can do that. I'd have to test that just to make sure, but for sure it can be created at the component part level, because you would go through this routing component wizard, say, hey, this is an electrical component, click next. What type of component is it here? Right, so type of clip. Of course, you would have the file open that you're using this routing component wizard on, so that's why it's not letting me show you guys here. But it would say for this specific type of component, whether it be a clip or a connector, it would say, hey, these are the parameters required to be able to use this as a routing component. For example, connectors, that's going to require a C point and an R point. And for a clip, that would require two axes. One axis is where you can rotate the clip around. The other axis is where the actual route would go through the clip there. So it'll kind of let you know, and it is a wizard, so it's kind of prompting you what you need or what it needs from you in order for that component to function properly. Right, so that's the routing component wizard. And the cable wire library wizard here, you can say create new library, and you would define those here, the cores, all that stuff. And it's pretty easy to do, but there is a little bit of work to do to create and customize this to work for your specific wire list there. And that can get saved as an Excel file or save it as an XML file. And you can do that there, right? So the piping and tubing functionality kind of works the same way. So you can see here we have an unfinished system here. So I can switch to my display state to show this route, right? And show the real view. Makes it easy to see here for me. So some of the built-in components for the routing in the design library, you can see there's electrical, HVAC conduits, piping and tubing, and within each of these there's there's those levels, subfolders. So flanges, elbows, tees, right? So SolidWorks has a built-in library of these to kind of get started with. So when I grab this welding neck flange, you can see that it has the intelligence in these parts to go ahead and switch and resize, right? So it's using those smart components for that. And then I can go ahead and choose a size here for the standard of pipe that I need. Right? We can go ahead and say always use elbows or form bends in the pipe, right? So we can choose those route properties, say okay. And then I'll create the stub length there for the pipe like it did for the electrical wires. So I can go ahead and add another flange here. You can see that resize, say okay. And there we go. We get those 2 points. Again, we want to go to the piping now and do the AutoRoute. We want this to be orthogonal routes here because we will be using those 90-degree elbows. And it's automatically routing using these parameters here so I can check for different solutions. This one, of course, goes through this enclosure. So I can take a look at other solutions. And this one looks pretty good. This is exactly what we want. So we can go ahead and say OK. And it's creating that subassembly here for the routing components. Those components are those flanges, tees, elbows, all that. And then when we get out of the route, it would show the actual pipe there as well. If we wanted this elbow to get welded right onto that flange, we can right-click on the sketch segment and say remove pipe. Right, so again, this is just using 3D sketching. You could have sketched this manually as well to create the route going in the specific orientation that you want to use there also. Right, so that's that there. You could also throw this on here as well. Now you can see that this one's a different size. So these are 4-inch and this is 3-inch there. Right, I can go ahead and, oops, click too much there. Right, so I can go ahead and place a reducing T anywhere on this route segment. I can use my arrow keys holding shift to rotate. Place that in the direction that I want. Right, and go ahead and select that size. And again, we can move this around. Again, this is just a sketch line on the sketch point there. You could have also done the split route and place that T right there as well. And we can go here and say AutoRoute. Say OK. Right. Under Define 3D Sketch, you can go ahead and add these dimensions here as well. And create this here very quickly. Right, we'll say 4 inches. Exit sketch, and there's your pipe spool. Right. So you can do that with the rigid pipes and tubing, flexible tubing as well. You can see some of those examples here. Works the exact same way as kind of everything we've seen already here, right? So you'll have these fittings. You say connect from here to here, auto route it. And if you need to manually create that sketch to show how you're going to be creating that tube to suit your needs, you can go ahead and do that as well manually with 3D sketching. All right, so that is the routing functionality. Again, that can save you a lot of time and reduce the amount of errors when creating those routes there very quickly. Right. So now we're going to talk about the advanced surface flattening or the surface flatten functionality, also available again in Premium. Right, so that's what we're working on here. Let me go ahead and close this. All right, so some industries, you'll want to throw some decals on your geometry, for example, this one here, we have this part. Where's my mouse? There it is. So you can see here, we have this curved surface, right? It's nice organic shape there, curved in three directions. And our goal is to put a decal on that, right? So we can use that surface flatten tool to do that. Other use cases for this I've seen, we had a customer trying to create like a cover on their structure, like a tent structure, and they were using wraps to do that, and they wanted to use this surface flatten tool to go ahead and do that as well, right? So cursor's disappearing there. All right, so we'll go ahead and open this part file, and that's our goal. We're going to create a flat pattern for this specific surface. Right? To do that, we can go to our surfacing tab here, activate the surface flatten, and here you just make your selection. So the first surface that you want to flatten, we're going to be choosing this one here. You have to select a reference vertex or an edge here to flatten relative to. So you can see here that it's creating that flattened surface there. And you can add additional entities as well. So like this kind of arrow there, right? So I can go ahead and select all these, and it'll translate that into the flattened surface also. So you can go ahead and create those and include that geometry like so, right? And we can go ahead and say okay. And what that does is it creates a surface body for that surface flatten here, just like that. Right? So if I wanted to isolate this, I can, and take a look at what that's going to look like. Right? Go ahead and hide that curve feature, and there we go. So if you were to right-click on this and look at the deformation plot, right? Whenever you're kind of wrapping something and it's got a curve to it, you know, you're going to have some internal stresses in that. So you can see here, this plot shows you where it's going to be stretching or compressing in these regions here. So another thing that you can do with this surface flatten, if we get out of that deformation plot, is you can go ahead and add relief cuts onto this geometry. So if I show those curve features again, we can go ahead and add these there to add some relief to those surfaces. And then when we take a look at that again, right, that alleviates some of those stresses in the material there. Right, so if you wanted to export this to manufacturing, we can go ahead and isolate that there, right? And you can actually export this as a DXF file. And you can choose a specific view or, you know, the faces and loops there. We'll just go ahead and choose the current view here and output that DXF file here as well. Right, so that is the surface flatten. Pretty useful tool for getting, you know, the flat pattern really that you would wrap on organic surfaces like this here. Okay, so let me go ahead and close that here. Last thing we're going to take a look at here is the assembly costing roll-up. So the part costing that's available in SOLIDWORKS Professional, so if you're not familiar with what costing does, is you can set up this template that has information about, you know, different materials, the associated costs with those materials, manufacturing operations. So, you know, say you're working with sheet metal, you can do the bending, you know, cost per bend, laser cutting, machining, machine parts, right? How long is your machine running? Different processes. You can set up this template that has an associated cost with it. So different use cases here for that, right? If you're a designer, you can go ahead and use that costing tool as a tool that you can use to design for cost. So if you are planning on machining something out versus using a laser cutter to cut that, you can see what the differences in cost would be for those between those two processes. Or if you are the manufacturer, you're a job shop, right? And we have customers doing this as well. You can take the time to set up your template and use it as a quoting tool also. So just a couple different use cases there for the costing. So that's, again, the part costing individual parts you can use in SolidWorks Professional. We're here talking about Premium, so you can do that with assemblies. So when we go into our assemblies here, right, we'll go ahead and take a look at this assembly. I'm just going to go ahead and open up a component here. Right, so the costing is going to be under the Evaluate tab. And we'll go ahead and activate the costing tool. All right, so let me go ahead and pin this down. So what this costing is doing is you can do it for machined or sheet metal parts here. There's different templates that you can set up. So if I go and take a look here at the excuse me one second. On the left-hand side here for the costing tab, you can see here that this template has a couple different setups associated with it. Of course, you're going to do the laser to cut out the profiles and probably the holes, and then the brake to create those bends. And that has an associated cost there as well. So you can create these templates and really customize it to, associate those costs that you would see in the shop, number of bends, any custom operations. So if you're, anodizing or anything like that, you can go ahead and add those custom operations as well. So you can see that it can be set up for different materials, right? Different lot sizes, all that stuff here. And it'll kind of give you a baseline. Then you can tweak any of these processes or the quantity, any discounting, all that. And then this will update. Right, so that's the part costing, again, available in SolidWorks Professional. So in the Premium version, right, that'll take the cost for all the individual parts if they have an associated cost with it. So you can see here we're using this assembly costing template now. And there's costs that need to be calculated for other components, right? Of course, I didn't save that one, so that's why it's here. But you can see here that it needs the cost for these three components there. The ones that already have the cost defined, when I select each of these here, you can see that purchase parts that you're purchasing there, you can assign a cost to that as well. These inserts, and also save the cost. So you can go ahead and cost the part here, save it, and it would go ahead and get imported here. You can also create custom properties as well, and that's how you save those costs, associated costs to those parts. And pretty much when you get into the assembly level, it just stacks all that up. You can choose to include or exclude specific components here, right? And then you can go ahead and do the cost stack up there. Right, for this lot size there, we can go ahead and say 10 instead of 100. And if I look at that here, right, the assembly, you can see each of the parts that have the cost associated with them, all the purchased parts, if they were included, you can go ahead and associate the cost for that too as well, and any custom operations here. So you can put a cost for assembly of those, right? And when you go ahead and do the cost, it'll go ahead and stack up that cost there. So again, the assembly costing available in SolidWorks Premium, and the individual part costing will be done at the SolidWorks Professional level. Thanks for attending. We'll see you next time. Bye.